I was there to bring them the truth and help them live good lives again. But I just felt like the people that I was meeting doing just fine without it. And the things that they believed were based on the same amount of conviction that I believe.
Fish thing at this layer, walking thing at this layer. There must be something between these two at this layer.
And I would read about evolution in there. And if my parents walked in, I'd close it.
Hide it behind a porn mag. It's just porn. I'm not,
Yeah.
I'm not looking around.
Yeah.
My guest today is Jon Perry, a scientific educator and animator behind the wildly popular YouTube channel Stated Clearly, where he explains complex science clearly. He's also an ex-Mormon. How on earth did that happen? Here to fill us in is Jon Perry of Stated Clearly. Welcome to the show, Jon.
Thank you. Glad to be here. I'm excited.
So, we've been talking for many years, but not a lot. But I think I reached out to you in 2018 when I was still a young Earth creationist, deconstructing my worldview. So, and you were kind enough to respond. So, thank you so much for coming on the show. It's good to kind of to finally meet you since 2018 when I first reached out.
Yeah, for sure. I mean, I get emails from a lot of people, and I hope that I'm being helpful and nice. I guess in your case, I was. So
yeah,
good.
definitely. So before we get started, what did you choose to drink today?
Oh, I'm doing like a blonde ale, which is
very, very far from your Mormon roots, I would say.
Oh, well, yeah. I mean, it's a light beer, so maybe.
Oh, okay. I've got myself Cooper's I can't see it there. Cooper's Pacific Ale, which is the closest that I have.
This is the one I'm doing. Dieu du ciel, which is like that means cool. God in heaven in French. I pronounced it wrong, but this was just a beer that I was doing a talk a while back, and they were serving that there, and it was good. And I was like, oh, maybe I'll get that one. I don't drink very often, but you know.
Yeah, right. That's Did you always we're kind of jumping ahead a little bit, but did you deconstruct and then start drinking, or did you always drink, or were you much younger? Like I was drinking in Australia, I was drinking at like 15, so I didn't get drinking before I became super religious.
Yeah. I left Mormonism in my early 20s. I think the first drink I had, I was like 27 years old.
Oh, so really?
I waited a long time. Yeah, I didn't just. I was pretty much like Mormon-y. Maybe I still am Mormon-y, after leaving. Maybe I say I'm a cultural Mormon still, except for sometimes I drink. Sometimes I'll have a beer.
Yeah.
But just because I don't know, I'd seen people leave the church and then go ruin their lives by just kind of going crazy. Like I think one of the things that happens when you're in a very strict religion, Mormonism's kind of like it's on the strict end. It's certainly not the strictest, but like mainstream Mormonism. There's like there are the like fundamentalist Mormons that they are super extreme. But what happens to people a lot of times when they leave, especially like the more extreme the religion is, they can't tell the difference between having a beer or doing meth. It's like these are all just the same level of wrong. So I think, maybe maybe it was like I just wanted to be careful and like think about stuff before I started adding things to my life, adding activities to my life. So, and even with alcohol, like I think I still have kind of the Mormon caution with it. Like, always, careful not to become an alcoholic. Like during COVID, I remember during COVID, I started drinking home alone sometimes because you couldn't drink in any other way. And I was like, oh yeah, I got to stop this. So I've always been very cautious about drinking. I mean, it is a neurotoxin. It does. If you drink too much, it messes up your brain. So sparingly.
Yeah. Well, my father was a pretty bad alcoholic. Or I should say is, because he's part of the program and AA, and they say that you're never really cured, kind of thing. So he's a really bad alcoholic, but he's sober now. But
he's recovered. Okay,
yeah. But but so I was always really cautious about it as well. But the funny thing is, I'm really lucky. Like, I haven't drunk in a little while because I've been going through a bit of a mental health journey, anxiety, depression, OCD. And when that happens, the furthest thing I want is a drink. I don't want a drink. I don't want anything that's going to make my mind altered or any way. And it's kind of lucky because my favorite thing to do is to drink by myself. So my favorite thing to do is to, like, especially if I'm like working on a project, or I'm like playing a video game or something, or I'm like researching something, I'll have a couple of drinks and it'll just be like, it'd be like this lubricating kind of motion where I'll just like ride the waves of my emotions and kind of go wherever I want to go. And I really enjoy that. But it's definitely something that even something that I've thought about on this show is like I need to promote. We did, like, when we first started, we had like sober months and stuff where, like, you don't have to drink alcohol in this show, but most guests will drink alcohol. But then I'll be like, okay, well, do like sober months and stuff, because it is important, because yeah, it's definitely a habit that can form quite easily, especially if it makes you feel good if you're anxious or depressed, and then that's a very slippery slope, I think. So maybe we'll actually touch on your history first before we jump into the evolution stuff, because what kind of Mormon, how did you grow up? Like, we don't really have Mormons in Australia. Well, we do now, kind of. I see TikTok ads for them, and I literally remember seeing someone on a bike and going, oh my gosh, there's some Mormon, because we knew, because they wore the white shirt and black pants. And I was like, whoa, Mormons, like, I can't believe they're actually here. And the Book of Mormon, the musical, has come to Australia, and I've seen that, and I'm a big fan. But I don't actually know much about what it's like for Mormons growing up. Like, what did you kind of believe, and like, how were you taught to view the world?
Mormonism's again, I'm talking about the mainstream, the Church of Jesus Christ of Latter-day Saints. That's what the mainstream Mormonism is called. That religion it's very much like all encompassing. When you're in high school, you go to seminary every morning before school. So you wake up extra early, you go to a class before school starts. Every Wednesday night growing up for me, there was like an activity. At the time, the church was linked up with Boy Scouts. And so that's what it was. It was Boy Scouts, but with kind of like a Mormon tinge to it. And then, Sundays, it's 3 hours of church. They actually reduced that now to 2 hours. But
sorry to interject, but is it kind of like how the Catholic Church is one big enterprise and they all believe the same thing? Is it like the Church of Latter-day Saints? Is it just one big thing, or is it like an umbrella term, like kind of how there's 45,000 denominations of Christianity? Is Mormonism?
It's even more strict than Catholicism, and like if you go to the Catholic Church in South America versus like France, they're gonna be focused on very different things. Like South America is very much focused, usually, not all the times, but a lot of them are very much Mother Mary first. Like in Ecuador, it's all about Mother Mary, and they actually link her to Mother Nature. In Ecuador, they have it's kind of like a merging between the native religions and Catholicism.
Wow.
And the Catholic priests tend to be okay-ish with that. But in Mormonism, there's like as little tolerance as possible to anything from the culture going in and changing the religion. So they're very, very strict. There's a little bit of difference in emphasis in different parts of the world. I know because I was a missionary in Brazil, but they keep it it's pretty much the same. You go to a Mormon church in Utah versus Brazil versus England, it's going to be very similar. That types of things. And actually, I'm pretty sure that they would teach you, it's going to be the same lesson in the Sunday school section everywhere on the same day from the same lesson book.
Whoa. Is there like praise and worship? I was part of a very charismatic, on prayer nights would have speaking in tongues and laying on, and in the church service would lay on hands and heal people, that kind of stuff. Is there any of that, or is it hymns? Is it?
It's hymns. It's not showy. It's hymns that are basically. The hymns are very similar to what you'd find in a Catholic church. A lot of them are from Catholic hymn books. they stopped really adding to the Mormon hymn book, I think probably in like the 1800s. So like there are some like American hymns that are in there and some that are unique to Mormons, but most of it's older, like
Yeah.
yeah, older Catholic type hymns for
It's
the most
it's
part. And it's only piano. They allow piano, organ, and I think maybe like violin. They allow that on special occasions, but they want it to just be like piano and organ and people's voices. So they don't.
mm,
There's not a Mormon church is not showy. It's
mm,
Mormon temples are very showy, but Mormon churches are not showy. Uh, they're very. It's just straightforward. It's a church. You go in there, except for one of the cool things they usually do have is they have a gym with like a basketball court in it and stuff. But
oh wow.
the chapel itself is just very. There's no decorations on the walls really. There's a couple of paintings of Jesus in the foyer. The foyer is, but they're it's yeah, it's pretty. They want to be humble in how they do things. They don't want to be manipulative, uh, and so a Sunday meeting starts with what's called sacrament meeting, and that's where it is pretty unique and a little bit more specific to your specific culture. Because in sacrament meeting, you have a bishop who's the leader of the church. He will call on several people. He will have talked to them a couple of weeks ahead of time saying, I want you to give a talk for 20 minutes on this topic. It might be the resurrection of Jesus Christ or something. And, so you listen to a lot of talks that are horribly written by people who are not good at speaking, right? Um,
Mm.
we don't even have like flashy preachers. It's just members of the church that we're told, and half the time they're terrified. Uh, and then you have a Sunday school meeting, which is another hour long, and that's an actual lesson that the church headquarters put together in a book, and it's going to be tying in like scriptures from the Bible and from the Book of Mormon and stuff like that. And that's going to be like because Mormons have a bunch of different scriptures. That they have the Bible, and then they have the Book of Mormon, Doctrine and Covenants, a bunch of these other books that they use as canon scripture. So Sunday school is based on that, and then they used to have another thing. I'm not sure what they got rid of something recently, but I don't go anymore, so I can't remember which one it is. But we would also then split up. Men and women would split up, and you'd go to a priesthood meeting if you're a man, and you'd go to Relief Society meeting if you're a woman, and then kids would go to their own thing. So there's like 2 hours of Sunday school basically. One is split by sex. That's how it works. So that first hour is where you can get local culture in because it's just the members of the church that are giving talks. They've just been assigned loosely a topic, and they've got to fill 10 minutes or 20 minutes or whatever. Um, and yeah, interesting stuff happens sometimes. Yeah.
Did you guys have any like this is maybe this is a very very Pentecostal-ish type thing to do, but we had these like when we split the men and the women in teenage years, I'm talking like boys from 12 years on, and girls, we would essentially, the guys were taught to have these like they were essentially anti-masturbation clubs. It was like
Yeah.
how to install software on your computer. It was like text each other when you want to masturbate, and then we'll pray, and then so you can resist the devil, and how to stop looking at internet pornography and everything like that. Is there anything like that in the Mormon Church, or is that more of a Pentecostal or I should say Protestant kind of?
No, I mean, I think part of the reason of splitting people up is so you can talk about stuff. I mean, but it wouldn't just be that. Like, I mean, it'd be that sometimes. They'd be talking about sexual things sometimes, but usually it would be like family stuff and trying to give advice that's, as the patriarch of your home, blah blah blah, So, yeah, it'd be stuff about marriage, it'd be stuff about dealing with yeah, your sexuality as a man,
Yeah.
uh, and how to handle that sort of stuff. But yeah, it'd be a lot of different things. In a nutshell, that's Mormonism. It's very intense. They have a word of wisdom, which includes no drinking. It's their health code. On the topic of evolution and Mormonism doesn't actually have an official stance on evolution. And if you go to BYU, which is the university
Mm.
that is run by the church, they teach evolution completely normally. I mean,
Really?
yeah, questions will come up a lot of times. So sometimes there's little asides about the religious conflict that sometimes happens with evolution, but basically they say the Mormons, the official Mormon stance is like, we'll just teach the science and we'll teach the theology, and if there's conflicts, that'll get worked out eventually when we know more. Is what is kind of, so they kind of have a, instead of dealing with the conflict and marrying the two together, they just kind of say, yeah, there's a conflict. Oh well, just let the conflict exist. And when you're doing science, just think about the science. And when you're talking, when you're praying to God, and so that was a pretty helpful way. And there's different. There's a lot of different ways that Mormons deal with it, but that's what I thought was the most helpful way. That is not what I got though when I was a kid. When I was a kid, I had a Sunday school teacher who was like hardcore young Earth creationist, and she taught us that we were going to learn about evolution, and that scientists are evil and they're going to try and trick you and all this stuff. So I was terrified when I learned in, I think it was like first or second grade, that we were going to learn about science. I was scared. I remember being in school like, oh no, this is what my teacher told
Science
me.
is going to get you.
Yeah. So I was like ready for it, but and it's really unfortunate too that she had got that message in my head, because I was a lot older. Like I was probably in high school, towards the end of high school, that I realized it was actually okay for evolution and Mormonism. Because as a kid, I would I was really interested in biology at a very young age. We I watched a nature documentary, and it talked about evolution, and I was like, this makes sense with things I noticed about my dog. My dog has the same bones that I do, and it doesn't make sense why, unless we're related somehow or something. Like
Mm.
it doesn't make sense that he has shoulder blades on the front and then hip joints on the back, and I've got the same thing with my hands and my legs. That was one of the big observations that I had made, and it made evolution super interesting to me. And I would watch plants too. When I was in third grade, we moved to a new house, and I was super nervous. I was very shy, and there was all these new kids, and I didn't want to talk to them. I didn't know how to fit in, so I just look at the plants in the ditch, and I noticed that as the water level in the ditch changed over the seasons, like different species of plants would end up taking over, because they did better in high water versus low water. And I noticed that there was like this battle between plants in the ditch.
Yeah.
So all these things came together when I first learned about evolution. I was like, wow, this is cool. And I thought that it was wrong, that I wasn't supposed to learn about it. So
Yeah.
we had an encyclopedia in our house, like a whole big collection, and I would read about evolution in there. And if my parents walked in, I'd close it. I was like scared that
Hide it behind a porn mag. It's just porn. I'm not,
yeah,
I'm not looking around. I'm
yeah,
reading biology.
yeah.
That's incredible. That's incredible. That's incredible.
But yeah, I would say in high school, I had a Sunday school teacher who taught us like, oh no, dude, that's totally fine. And
Yeah.
he pointed out there's all the stuff at BYU, and they're fine with it. I was like, okay, good. So for me, that was a huge relief, because I didn't want this thing that was so interesting to me, and the evidence was seeming so strong to me. I didn't want that to be in conflict with my religious views. So my
Mm.
the reasons that I left religion, I don't think had anything to do. I mean, maybe science, maybe evolution and stuff, kind of, especially when I was younger and haven't had this conflict between the two. Maybe that caused a little bit of attention that helped me think more critically. But I don't, I don't think that had much to do with why I left. The reason that I left, it was just I was a missionary in Brazil, and I was there to bring them the truth and help them live good lives again. But I just felt like the people that I was meeting, a lot of them, they were doing just fine without it. And the things that they believed were based on the same amount of conviction that I believed. And it just seemed to me that there's no way that I just happened to have been born in the one true correct church. It's much more likely that religions in general are cultural inventions, and that all of us have tricked ourselves a bit into believing in them. So that was the conclusion that I came to. It was basically just on that. Like, if everyone's so convinced, then maybe humans are just good at getting convinced by stuff like this, and
Mm.
the most likely conclusion is that these are cultural inventions. That's the line of reasoning that made me leave Mormonism.
That's quite interesting because when I was deconstructing, my thoughts were along the lines of like my God belief was tied to all of these pieces of evidence. I would call it. So
Mm-hmm.
the Bible was evidence. My experiences were evidence. Answered prayer were evidence.
Mm-hmm.
All these things. And it wasn't until I started learning epistemology and science and how to think critically and what fallacies are and why certain things you can't, like, if something's got bad logic or poor logic, you can't then like it, you need to find another way to make something work, because otherwise it's fallacious, doesn't work, and
Mm-hmm.
and it's a good way to be fooled. And when I kind of learned that, I realized, like, I started trying to investigate my worldview. Is the Earth 6,000 years old? What evidence is there for that? What if the Bible is the inspired word of God? What if it isn't? Let's look at the evidence for and against. And slowly but surely, those reasons for belief, I started to not have them anymore. And the only thing I was left with was a subjective, internal, emotional connection. And then I
Yeah.
asked myself,
Yeah.
is that a good enough reason to believe in God? And even though
Mm-hmm.
I want to believe in God, and even though I still have those warm feelings towards God, but since then I've learnt a bunch of things, like how the Bible endorses slavery and take the virgin girls for yourself and things like that. And I've learnt things that I don't necessarily approve, or definitely don't approve of.
Yeah.
I still have these warm feelings. There's a cognitive dissonance that I have, these warm feelings towards God, but I'd have to admit that I just don't have enough reason to believe in that God, or to conclude that God is real.
Yeah.
So I just go, okay, well, I just have to admit that I just don't have the the reasons to believe, like enough reason to believe that someone else couldn't just say for their religion as well.
Yeah.
Um, but but something that I've always appreciated about you is you make evolution interesting, and your passion for biology is infectious. And
Oh, cool.
I remember watching your videos. I remember watching Aaron Ra's series on the foundational falsehoods of creationism, and especially his series on Noah's Ark. And he talks about how paleontology disproves the flood, and the way he describes that in there is just incredible. And I actually wrote this little when I first reached out to you in 2018, I sent you a screenshot of this document that I was working on, which was called The Objective Truth of Origins, where I was looking at every one of the pieces of evidence that I could find in paleontology, biology, everything,
Mm-hmm.
And one of the latter notes in this, and this is when I was still a theist, I think. Yeah, I definitely was still a theist. But I wrote this. I wrote, if the earth was created by God and the Bible was inspired by God but written by man, shouldn't the earth be a better source of evidence for the origin of life? If
Mm-hmm.
God truly did create the world, then it must have been him who laid the fossil record revealing evolutionary history. It must have been him who conceived the genetic pattern, which also traces the exact same course. It must have been him who created stars billions of light years away that we can see with our own eyes. It must have been him who created chimpanzees with DNA that is 98% identical to our own. It must have been him who created all the other evidences that point exclusively and in brilliant detail to a 4.3 billion year old Earth, not an Earth a few thousand years old. To put the words that were inspired by God, written down by man, translated by man, edited by man, canonized by man, and subjectively interpreted by man over God's direct work seems dishonest to me. I believe in God, just not a deceptive one that would plant evidence to try and fool us. I put deity above doctrine. And part
Mm-hmm.
of that was paraphrased from Aaron Ra's video, I think, and a bunch of other things that I'd found. But that kind of became my mission statement when I kind of finally decided to kind of accept. You can hear my dog barking. Apologies. You can finally start to when I finally started to accept evolution, is I
Mm-hmm.
realized, okay, well, I do believe in God, but it must have been him that gave all this evidence.
Yeah. It's interesting your line of thought there, because that's very, very similar to the way that Christians in Europe started thinking about the Bible like in the early days of, so this is kind of like after the Enlightenment, you start to see this huge push within Christianity to study nature. You have natural theology, which is like, I think, well, William Paley wrote a book, I think, called Natural Theology, and he's kind of considered like he's the dude that you think of when you think of this. But there were a bunch of people that were going down this line of reasoning, and I think the Catholics had been doing this since like the Middle Ages. Like you had you had all these Catholic friars that were just, they would translate ancient texts of all kinds into the modern language. So even like Greek and so on, they were getting all this philosophy from all over the place. You have this enlightenment that happens with this kind of merging with Christianity and the ancient philosophy. And then you have this natural theology that comes about where they're like, look, yes, the Bible is God's word, but if God created the earth, then it's literally what he made with his hands. And their thinking was that it's the earth is going to be a much more difficult book to interpret. So we got to be careful with the conclusions that we draw, but it's literally like interacting with God's creation. So if there's a conflict between the two, and we're really sure that there's a conflict between the two, we should probably side on observation of the actual Earth, right? So you see that happening in like Adam Sedgwick's writings. Adam Sedgwick was head of the geology department, or like the first geology organization official in England. And this was like a little bit before Darwin's time, and he was then contemporary with Darwin. So I think he might have been, he either was or could have been Darwin's geology teacher when he was studying geology. But he, early on in his career, he was promoting the flood geology because he found all this evidence of floods all around the world in his geology. And when he became the head of the Geological Society, he was reading all the papers about it, and he realized from this like overview perspective, like these aren't one flood; these are lots of different floods in different areas at different times. And so there's a really crazy speech he gave where he comes out and says that that's the case. He's like, I was tricked. I wanted too simple of a connection. I don't know if there's ever going to be a connection directly to the Bible story and geology, but this is not it. And basically, that was kind of the end of flood geology. He proved it in this presentation and a series of papers, I think, afterwards, that these are not one global flood like we thought. These are a bunch of different events, and local catastrophes happen, but there's no evidence of a global catastrophe. So that was.
Have you heard the work of Kent Hovind? Because he would disagree.
Yeah. So I have a video. So I did a series for Stated Casually, my second YouTube channel, and that, I think maybe you saw that too. But that's where I actually have a video on this presentation, because he says that the reason that evolutionists, is what he calls them, the reason that evolutionists deny a global flood on Earth is because of the theory of evolution. And so I pointed out that is before evolution was published, the Christian geologists, like hardcore, the guy was a preacher, they already concluded that no, there was not a single global flood. And the evidence for that has just mounted since, that these are separate events that we're seeing.
I was wondering if you could give us like a kind of historical perspective of where the world was at right before the cusp of Darwin. So Charles Darwin, obviously the main person behind the theory of evolution by natural selection, but like, what did the world look like? Yeah, well, there you go. So that's a new shirt that you've got out, right?
Yes,
Stated Clearly merch.
The new Stated Clearly T-shirt. Darwin.
That's awesome.
Similar to the drawing I have behind me too.
But I'll have to we'll put a link in the description, so if people want to purchase that shirt, they can go check that out on your store. But and I'll have to get one. It's awesome. But so what was science like before evolution? Did people generally accept that we all came from Adam and Eve, I guess, in the West, Was it like that? Was it like, or was it kind of like abiogenesis now, how we go, oh, we don't know. We're working on it, but we don't know how like life first started.
So if we're talking about kind of right before Darwin, the scientific community was not interested in being biblical literalists, but they were Christian mostly. Okay, I'm talking about the scientific community in England and Europe, England, France, Western civilization, right? They were like, the Bible was there. That was a big part of their worldview for almost everybody. But they were kind of over this whole thing where the science has to match the Bible or it has to match what the Pope said. They had been upset about the things the Catholic Church had done in the past to people that they considered heretical scientists and stuff. So this is after the big Enlightenment era. So you've got ancient Greek philosophy mixing with Christian philosophy, and that's kind of powering the scientific movement. You have what I talked about earlier, where a lot of these Christians thought that it was their duty to study the earth, the creation itself, to get to know God. And they were incredibly strict on the logic that they used when they were doing that. And they really didn't want to put the Bible ahead of that. They didn't want the Bible to interfere too much with their activity of trying to interpret the earth, because they didn't, like you said in the thing that you wrote, that if the Bible was inspired by God, written by men, then, well, the earth is actually God's work. So for a lot of people, their scientific studies, that's how they worshiped God. It was considered a very intense and pure form of worship. There was also a lot of secular thinking at that time already, where people are just, I don't know if they really called themselves atheists or what, but they didn't care about any of that God business that much. They were interested in the science. But you had a type of creationism that was mainstream at that time. And that this type of creationism said that everything was created in its current form and a sort of an essential form. So like there's kind of an essential rabbit, right? There's like a perfect rabbit. And then there's deviations from that. There's a perfect man, which was Jesus, right? For the Christians. And that's kind of like that goes back to Plato. So that's kind of a merger.
Forms, right?
Yeah. That's a merger of Plato, and then Aristotle kind of attacked that, but he had something similar with the essences and stuff. So people were mixing these old views with Christianity, and
so
they had. Yeah.
If you were to crossbreed a dog, that dog that you crossbred would essentially be like a is the right word bastardization of like the perfect dog, the dog form? Would that be like a kind of corrupted or not true representation of a dog?
It's call it a mutt, right?
Yeah.
But
yeah. Yeah.
Yeah.
Hey.
Yeah. The mutts were I mean, people had, I mean, it was very different from group to group, but yeah, that all of these ideas were like, I think probably at that time people had this idea that dog breeds were like, this is the perfect, I don't even know what dog breeds they were breeding back then, but this is the perfect bulldog. This is the perfect, whatever. I don't know dog breeds very well, but the, they had this, there was this idea that species are immutable. And that was a very important doctrine that people had. And it was just kind of like, it came from the religion and it bled over into the science, and it was just kind of unquestioned. It was like not even something you would think to question. But that was starting to change already before Darwin, because we started studying fossils. We started finding weird things where they blend different animal groups together, blended. Like, that's weird. You had the French geologists were like, dude, there's major differences in the animals in different layers. Like, it's like different worlds. And so there was this view of catastrophism, I think I'm saying that right, where everything would go extinct and then God would create something again, which is completely not biblical, right? But they didn't have a problem with it. It was like, well, that's what I'm seeing in the rocks. So maybe he just didn't write about it, but
I,
that he,
I, I remember trying to think about how kangaroos would hop all the way to Australia and koalas would crawl all the way to Australia. I worked out there were 19,000 endemic species in Australia that would have had to crawl or float or hop to Australia where I live, and and then I think someone suggested to me, well, maybe after the flood, God just repopulated the earth. Like just put kangaroos here, like that's where they're supposed to go. And I was like, well, then kind of defeats the purpose of them being on an ark in the first place. Like, what's the purpose if God's just going to like make everything, put everything in its right spot, and like create koalas and fully grown eucalyptus trees that they can eat off in Australia after a worldwide year long flood? Like, what's the point of them getting on the ark in the first place?
yeah,
Yeah.
yeah.
So
It's things get silly, but I guess if you have, yeah, you can just say a miracle, I guess, right?
yeah, exactly. Yeah, a miracle just go to the gaps, right? Anything that we can't,
Yeah.
it doesn't make sense. We just say God did it.
Mm.
It's a miracle. I remember listening to a LibriVox recording of people reading the Voyage of the Beagle,
Mm-hmm.
and it was quite interesting. I haven't actually read the Origin of the Species, or listened to it, but I've read the Voyage of the Beagle. But can you just refresh your memory? So he's on this journey, right? Like
Mm-hmm.
around the world, sailing to different islands and stuff, and kind of studying things. When does he start to develop the idea that maybe life wasn't always these fixed forms? Maybe different things evolve.
Well, geologists had already said this. Geologists were talking about the deep history of Earth already and how it changes gradually in many cases. And so he was just thinking about that a lot. He was also thinking about Malthusian catastrophe, I think is what it's called. But it's there was an economist talking about uh, the struggle for existence that happens. So when economies are strong, everybody reproduces and has lots of kids, and then when the economy fails, things go to crap, and it's only those that happen to be really wealthy that end up being okay, and everyone else has to fight over scraps. So Darwin was thinking about that as well, and he kind of put the two together. Like, okay, I'm seeing, especially when he was going to islands. He'd be like, I see animals on these islands, and I see similar animals on the mainland, but they're different. And not only are they different, they're like specifically different to survive well on this island and slightly different on that island. And I can see that it's an adaptation. It's not just different, it's different in a good way for that specific island. So he started just putting these things together like, okay, I think there's change. Species are mutable, and they appear to be mutable in a good way. They're not just randomly mutable, they're mutable according to their environment. And if the environment was changing really slowly, and if you had just changes popping up from time to time, you could get natural selection. You could get some individuals would happen to have new traits that make them better at surviving in that environment than their parents did and then their siblings do. And they're going to end up having more offspring. And if that new trait happens to be heritable, if they happen to be able to pass it on to their offspring, well, we're going to get a gradual change. All of the negative changes will get deleted because those with negative changes just won't do well. They won't have as many offspring. And all of the positive changes are going to add up. And so you're going to get cumulative changes to happen. Small steps accumulate into large differences in phenotype and body shape and form and function. And you get adaptive evolution. So that was his thinking. And yeah, it's based on all these other things that other people had come up with in different fields. He pieced it all together then at that time. I think a lot of his ability to do that had to do with the fact that first of all he was traveling the world, he was seeing all these different ecosystems. Second, he had back home, he had these beautiful museums full of specimens, at Oxford. And I don't know if the Natural History Museum was open at that time. I don't think it was, but he had access to all these amazing specimens from all over the world. He studied them. So it was this combination of the thinking at the time that was there, plus his access to all these different organisms, and then him seeing them in the flesh when he was traveling, and it hit him, and it hit him hard. And it's interesting because Alfred Wallace, at the same time, was also traveling around the world, also English, and he came to the same conclusion. And that kind of gives you this idea that it must have just been that there was so much similar thinking at the time, and so much access to similar data, that this finally became so obvious that you couldn't deny it. So it happened. These two separate men. It happened independently. Darwin ended up getting most of the credit for it, for kind of an accident of history. But
yeah. And apparently, is this true? My memory might be failing me, but when he first published his idea, they didn't think it was that big of a deal. They said nothing.
Well, him and Wallace published it together, and it wasn't considered that big of a deal. And then Darwin published his full book he had been working on earlier, and then everyone's like, "Okay, this is kind of a smack in the face." Like, I think that's why Darwin got the credit, and Wallace is kind of forgotten, is because the two of them wrote a paper together about it. They were in correspondence privately, and it came up that they both had the same idea, and Darwin was working on his book at the time, and he's like, "Oh no, I'm going to get scooped." So the two of them made a deal to do a paper together first, and the paper was not very impactful, but the book was like a bestseller. Tons of people read it, like lay people even. Darwin was already kind of a famous writer from the other stuff he had written about his voyages and so on. And he did such an excellent job in that book, laying out his argument. I mean, it's kind of, I would say today it feels kind of wordy and a little bit dry, but he was being careful. He was being super careful because he knew all the arguments that people had against it, and he did not want to leave. He wanted to be sure that this was going to be rock solid when he published it. So I still think it's an interesting read. I've read it a couple times. Some stuff is wrong in it, but it's insane how much he got right on his first pass. But it was a crazy time in history, and it really changed a lot of people's thinking.
What would you say to someone who says, "I don't even know how to even ask this," because it's kind of putting the cart before the horse. But what do you say to someone who says there are boundaries, and that it'll always still be a dog kind, or it'll always still be a fish kind, or a bird kind? Like, what do you say to people who say they'll never change into different types of animals?
Well, we see those boundaries blur when we look at fossils. So and this was something people saw before Darwin. So it was really tripping people out. Like, they would see that there's a blurring in the fossil record of different major groups of animals. I mean, Archaeopteryx is a really good example because it's obviously a dinosaur, but it's got feathers. It's got hands with 3 claws, super obvious 3-clawed hands. It's got a big long lizard tail, reptilian tail, and it's got feathers on its wings. It's like, well, crap. That just completely blurs the line between our supposed distinct types of organisms. So that was trouble. So Richard Owen, who is the one who started the Natural History Museum in England, like the big famous one that all the other ones are based on today, he hated evolution. He rejected it till he died. He was an older man by the time when Darwin published his book, but he had to admit, we've got these transitional forms, which he didn't quite know what to make of them. He just said, well, maybe God was just using an archetype, and he kept on just fiddling with it. And so you get That was how he tried to explain it, but it just did not. It just
Yeah.
didn't make sense of the data. There was too much data of these transitional forms. We see them all over the place. We see them with, we see them in the human record. All these apes that are progressively more human-like. We see it with whales. You can see the progression of whales. You can see the transition from an ancient reptile-like thing to mammals. You can see that happening. And there's entire groups of animals that are like in between mammals and reptiles. And you see all of these transitions all over the place. And that's our fossil record is garbage. It's very rare for an organism to fossilize, but still we see all of these tons of these transitions, and we just over and over and over again. So the idea that there's a strict boundary doesn't seem to be. That's not what we see in the fossil record.
What I love about scientific theories like this is being able to, and when I say theory, I'm not using it in the term lay people use it. Theory is obviously the graduating point of ideas in science. But what I love about scientific theories is being able to make novel, testable predictions with that. That's where the power of scientific theory is. Like, so I can go out into my backyard. I could get some instruments and I could dig down 100 feet or something, right? And I can predict what I'll find at different layers of the Earth, and that lines up pretty perfectly with the theory of evolution by natural selection.
Mm-hmm.
And you're like, okay, cool. Like you got different stratas and stuff. That's a pretty good prediction. But like the stuff that really blows my mind is like stuff like Tiktaalik, where it's like
Mm-hmm.
we have fish thing at this layer.
Mm-hmm.
I'm going to dumb it down for everyone. Fish
Yeah,
thing at this layer, walking thing at this layer. There must be something between these two at this layer. We haven't found it yet, but we know this layer is at this part of the Earth, and we can go looking for this fossil. Let's go look for it. And then they do, and then they find that thing. For
yeah,
then Tiktaalik, for evolution then to be like false would be the wildest coincidence of
yeah,
like it would be very strange for that to come
yeah.
true. And we just see things like that happen time and time and time and time again. But yeah, we still have
Yeah.
some common criticisms of
Mm-hmm.
common creationist criticisms, and I'd love to run some of them through. Oh my gosh, the drinks are kicking in. Run some of them by you,
Yeah,
if
yeah,
that's okay.
yeah.
Okay, so the first common creationist criticism is that evolution by natural selection is irreducibly complex, meaning that life is too complex to have evolved step by step. I heard a creationist once say, if I've got to wait 6 million years to go to the toilet, my bladder doesn't work. Like how does that work? If I have a bladder but I don't have the ability to, I don't have an exit for that bladder or something. Like how does that work? What does half an eye do? What does half a
Yeah.
stomach do?
Well, in all of those cases, let's talk about a bladder, for example, because that's what you brought up. But maybe we could talk about the flagella, bacterial flagella later, because that's the one that gets used the most when people talk about irreducible complexity. The argument is that if you have a complex organ or structure or system with a multiple interacting parts, and you need all of those parts working together in order for the thing to function, then they say that it could not have evolved. But in the case of a bladder, for example, if you look at the evolution, I haven't studied specifically the evolution of the bladder, but I do know in general the evolution of organisms that now today have bladders. You have these organisms started out as very small animals in the ocean with flattened bodies, and those flattened bodies were just using the water as their blood. They didn't have blood, so they didn't have to filter urine out of their blood. They had a digestive tube, and then they had a flattened body, and so they were able to pull in nutrients through their mouth. They were able to uh, dissipate waste and stuff through the water itself. Just the seawater acted as their blood. They got their oxygen through the seawater. They didn't need a heart. They didn't need blood vessels. They didn't need any of that because they were so small, and they were, either flat or had a high, a lot of surface area to dissipate that. And then eventually you start to get this division where there's the feeding tube, and then around that feeding tube is liquid, and then you have cells around that, and that allows you to get a little bit bigger because you can dissipate food and stuff through that liquid to get to all those other cells around you, and then those cells can communicate with the ocean and expel waste that way. And then you get bigger still, and you start having things where the liquid inside the body gets sloshed around. There's a muscle that can slosh it around, and then you end up getting these tubes that form in there. And all of these different changes allow you to get bigger. You can now handle being bigger because you have better circulation internally. And then eventually you get the evolution of these organs like bladders and so on. This happens gradually, and you don't need them before you have them because you're small enough, or you're doing something else in some way that allows you to get by without it. And then when a bladder-like structure forms, it's then useful, but it's an advantage. It's not necessary. But that advantage then lets you get bigger still, and then it becomes essential. So you have things that start out as perks become essential as time goes on. You kind of think of this like, sorry.
Go, what were you saying?
This is just one of the way that irreducibly complex structures evolve. And there's kind of a funny example is like, I don't know if it was Nike shoes who first, I think they were the first ones to do these super lightweight shoes for runners. When they first made them, it was a huge advantage to the runner. Now it's entry level. You have to have good shoes to even compete because everyone's going to destroy you if you don't have good shoes. And the same thing happens in biology. Like, the huge advantage just becomes entry level. You have to have it once you reach a certain size, or your neighbors all have it and they're competing with you, and so you have to have that too. You do have things that are essential in biology now that were not essential when they first evolved for many different reasons. Yeah.
I make this joke that my friend has those Nike shoes that are like really good Nike shoes, and I sent him a video, and he goes, yeah, he goes, everyone uses them now, and I said that's why you can run 30 kilometers and I don't run half a kilometer, and he's like, yes, it has nothing to do with your fitness levels or being overweight. It has everything to do with the shoes you have. And I was like, exactly. I was like, this is why you can run 30 kilometers, man. This is, it has nothing to do with anything else. And this is so back to what you're saying. Is that also why we have vestigial organs, right? Because eventually, like, they started as maybe like our pancreas, or I don't even know if that's a vestigial organ, but parts of our body that were once used for something have kind of changed to something else, and then we don't need it as much anymore. And then but it's still there in our DNA, so we still grow certain things. Is that kind of this idea?
Well, so a lot of vestigial organs are the result of selective pressures changing over evolutionary time. So that I would say probably my favorite one for humans is when we get cold, we get goosebumps, right? And it raises the hairs up on our arms. And if you're a fully furred animal, that's gonna help you stay warmer. When you raise all of your fur, you've got more of a buffer between you and the outside elements. But in us, it doesn't really do much at all. So that's because selective pressures have changed. We no longer have fur. We stopped needing fur. Fur was probably a problem at one time. Maybe it's not clear why, but it's possible that we had invented clothing already, and we just had lice problems, and maybe that's why we ended up going bald. But eventually we were bald, and essentially bald, and that adaptation wasn't useful anymore. But we still have it. It's just still there because it just hasn't gone away yet. But it's evidence that selective pressures have changed.
I wonder if the losing of fur, it was a subjective a subjective like human desire to the person with the less fur, the ape with the less fur, the creature, the animal, the thing with the less fur would be more attractive and therefore have more partners. I'm not sure. I have a friend who is from Malaysia, and she lives in the Philippines at the moment. And she will show me photos of her friends, and they will be comparing, and she'll be comparing skin color and saying how like they all want to have lighter skin because the darker skin shows that you're a lower class because you work out in the fields. And I just see them all like to me they just all look like I don't pick up on that nuance. It's relevant to me. It's not something like I've never talked about. But for her and for their community over there, having a lighter pigmentation in their darker skin is something that in this group found valuable. Well, not valuable, but aesthetically pleasing in this place and time.
I think that's a very temporary cultural trend in that particular culture. So, I mean, because you had like in the 70s, you had the opposite thing in the U.S. Everybody wanted to do fake tan.
True.
So I mean, those are like little cultural trends that are going to be specific to one culture. I don't think there's even consensus as to why humans lost their fur, but we did. I mean, that's for sure. If you want to think of selection pressures that could have done it, it could have been sexual selection for some reason. It could have been that people found mates more attractive when they had less fur, maybe. But it's also just, I mean, think of how much time chimpanzees spend grooming each other, and almost pretty much all primates spend grooming each other. The reason for that is that they're riddled with parasites. So, and those parasites are really good at hiding in your fur. It's a lot harder for us to get parasites, like lice. You can get head lice, and it bothers your head a little bit, but
so less time grooming, more time having sex, more babies,
more time doing everything else. Yeah. Yeah. But I don't think that there's strong consensus. I mean, I haven't looked specifically at.
Yeah.
I read an article about this years ago, and back then there was not consensus. People argued, they had different hypotheses about why we lost our fur, but for whatever reason we did. So, but we still have this vestigial trait of trying to raise our fur to stay warm, which is really fun.
Or to look bigger as well. Like if you get scared, is it another reason?
Yeah, it can make you. It'll make you look bigger. And then you can also think of, well, why are we keeping that trait around? It's possible that it just hasn't gone away yet. It's also possible that, well, it is still useful for certain things. Like,
there's no selective like no one's choosing essentially who to mate with based on if they get goosebumps or not, right? So there's no point, no reason for it to be selected out. Isn't that how it works?
Yeah. Well. Also, it might even you can lose a trait just if nothing's selecting for it. So if natural selection is no longer keeping that trait around, it can just leave through what's called genetic drift. Any mutation to that trait that breaks it, oh well. There are more deleterious mutations than there are beneficial ones. And so things tend to get erased just by default, but it takes a while. Yeah. If something's not being selected for, it's going to get erased in general.
Okay.
But actually, I mean, you could think that, there actually might be some sort of social things that are keeping hair raising going. Like you do get a sensation still, which is an interesting sensation. They can tell you, oh, I am cold. My cold thing got triggered. I notice it more than I would have otherwise. Maybe I'll put out, maybe in some cases that's actually important for survival. But so yeah.
Okay, the next common creationist criticism is there is a lack of transitional fossils. Where are the transitions? But more specifically, and this is the question that I had reached out to you about back in 2018, that I was, I couldn't necessarily find a good answer at the time, was how come we have, say, 10 T-Rex skulls and they all have the nostrils in the one location where maybe its predecessor, the nostrils were back here or something. Why do we all have them? Why do all T-Rex skulls look like a T-Rex skull? And we don't have like heaps of like heaps of transitions of that T-Rex skull? Why do we only seem to have like snapshots of T-Rex or snapshot of, I don't know, another, like for some reason the drinks are kicking in and I can't think of another animal, some other animal. Do you know, why do we only seem to have snapshots and they all look the same? And we have heaps of them that look the same here and heaps of them that look the same here, but we don't seem to have lots and lots of sprinkling of transitional ones in between.
Yeah. Well, so you're asking about stasis. So animals can stay in a fairly similar form for a long time in the fossil record, and then quickly they'll change. You can tell they're related, but quickly they'll change. And it's been a while since I looked up stuff on T-Rex, and I don't even know the names of their relatives, but there's a whole bunch of T-Rexy looking things that evolved before T-Rex did, and then you see T-Rex dominate. But when you think about the fossil record, now this is not always true. This is mostly true. I'll talk about Lagerstätten as well. Lagerstätten are an exception, but for the most part, fossilization
in Germany
fossilization is super rare, right? And just think of it like, of all the roadkill you've seen in your life, how often do you see it stay there for ever? It just doesn't. Things eat it, things pick it apart. Bones will just decay actually just in the elements without anything eating them, just through oxidation and so on. So in order for something to become a fossil, very specific things have to happen to it. It needs to be protected somehow. A lot of fossils, things will fossilize if they die like in a lake. So if they drown in a lake and then they settle to the bottom in the sediments, and there happens to be a lot of sediments in there, they'll get buried by those sediments and they can be preserved, especially if there's there's not a lot of oxygen and stuff in that because of different chemical reactions that are going on. So there are some things that can lead to fossilization, but those processes are rare. Most stuff that dies gets eaten, destroyed, decays before it can ever become a fossil. So what that means is that the only things we ever see in the fossil record, for the most part, there is an exception, but for the most part, the only things that we see in the fossil record are the things that are super common at that time period. And so you've got a species that has just dominated and it's everywhere. So if you were to see the fossil record from today, you would see humans, you would see cows, you would see dogs, you might see crows. There's a handful of things, but you're not going to see like that one Amazonian frog where there's like, 2,000 of them total that are alive. You're not going to see all the rare populations. So you only see those animals that became dominant at their time. And there's only one version of a thing that becomes dominant at a specific time. Like there's lots of birds, right? But there's not many that are as dominant as crows in North America. And so you're much more likely to see a crow than a like woodpecker, right? In the fossil record. So if, millions of years in the future, people looking at our time period. So you're not going to see, when a population is small, you're not going to see them at all in the fossil record. The one exception for that is Lagerstätten. Lagerstätten is an area that for some reason it fossilized almost everything all at once. And it was named after the Lagerstätten in Germany, which is where Archaeopteryx is found. And there was this giant lagoon, really, really salty, toxic lagoon, and everything that would swoop down and take a drink from it would like die. And they would fall in this and they would get fossilized in the bottom. It was full of these sediments, exactly the sediments that I was talking about earlier, where they can fossilize things really easily. Bacteria was not surviving well in there. It was too salty and so on. So you had pretty much everything that fell in there died. Every once in a while, the actual ocean would breach this thing and dump animals from the sea into it. They would all die. So we have a beautiful snapshot of pretty much everything that was alive at that time in that region.
I want to overlay like Jumanji, doon, 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 like drums as you're saying all that stuff, because it's so wild to think about how crazy the Earth was back then, like with These,
Yeah.
yeah. Anyway.
Yeah, and just this one little region, there was this evil trap where it looks like delicious water, and you swoop down and take a drink. You're a pterodactyl or you're an Archaeopteryx or whatever, and you take a little drink and you just start gagging and die. Yeah, it's what we call an ecological trap. Another one of these is in California, the La Brea tar pits. That was another ecological trap. Animals would get stuck in it, and then they'd start panicking, and that would attract wolves and other predators in, and they would jump on the body, and then they would get stuck in there too. So you have all these. It's a really cool trap because it's mostly predators. You have giant mammals like these mastodons and so on, and then tons of dire wolves and saber-toothed cats that are trying to take advantage of these stuck animals, and they die too.
Yeah.
Uh, and then you have some beautiful ones. There's a volcano. I think it's in Nebraska where this volcano killed everything, and it killed them by suffocating them and then burying them in ash. And so you have it was light ash too, and it was hot ash, so it killed all the bacteria basically barbecued everything. But it was so light that it didn't crush them. So you have beautiful skeletons that are still fully intact. These were big mammals, like there's like rhinos, and this was after the extinction of the dinosaurs and all that. But
Yeah.
that's a really cool fossil bed. And then you have another one, the Cambrian. There's a couple from the Cambrian in Canada. The Burgess Shale is one where it was like there was some sort of these are all sea animals that were living on the seafloor, and there was some sort of a repetitive volcano or clay slide that kept happening, and it would just slide and just bury everything and kill it. And then the ecosystem would recover, and then bam, they get buried again. And so you have layer after layer of just beautiful preservation of everything that was there. So you do have these snapshots, but it's very rare. Mostly you only get who was the most common animal at the time. Sometimes we'll find a part of one of their skeletons.
Yeah. Okay. All right. So that makes sense. The Cambrian explosion. So this is one that I don't necessarily have a good answer for, but why do we all of a sudden see this massive explosion of complex life all at one time? And before you answer, I will say that I interviewed Not So Erudite. I'm not sure if you know who that is. Kyla. She's a streamer, and she is a Christian, and she said that she would get, and I quote, I would get like these goosebumps being like either this happened just by accident or I'm watching some sort of infinite God paint a fucking masterpiece, and that's pretty cool either way. So to her, she said to me, I'm not sure if this was on stream in the episode or if it was off stream, but she said that to her, the Cambrian explosion is like, that's God, like whatever. And I was like, is that kind of God of the gaps? But it's like something had to have given life this big explosion. It makes no other sense that we have kind of not much fossilization, and all of a sudden this explosion of complex life.
Mm. So part of the Cambrian explosion is an artifact of the fact that we've got some nice Lagerstätten that show this area, so we can see all the animals that were there. So we have a lot of fossils before the Cambrian, but they're super rare. They're few and far between. We have a lot of evidence that before the Cambrian explosion, there was a lot of wormy-like things that were digging in the dirt. They were animals. We have a couple of their fossils. A lot of them were worm-like, and they lived underneath the soil. And we have a lot of trace fossils of them. Like we can see when you eat sand and you're taking bacteria out of that, that's your food. Then you poop out the sand. That makes a very distinct structure. It actually tends to fossilize pretty well. So we have a bunch of these structures. We have a couple of actual full body fossils of animals from that time. And then we very much do see a real and dramatic diversification. It wasn't an explosion like all at once. It was over several million years, but you do have a dramatic change in animal diversity. And the biggest thing that happens there is things start to get exoskeletons. And that lets things fossilize a lot better, which is awesome. We can find their fossils even when there's not a Lagerstätten. So we do have a pretty abrupt change, and it's scientists debate about what's causing this. There's a couple of things. I mean, we had a bunch of animals beforehand, so the animals were there. What caused this sudden change? We know that there were chemical changes that happened then with like oxygen levels. We know that there were differences that happened causing the oceans to be more suitable to building shells. The chemistry of the ocean had changed. But a lot of people say it's like, I think a lot of this was an evolutionary arms race. You have a lot of predator prey innovations, a lot of armor to protect yourself from predators, and a lot of crazier, scarier tools for killing stuff that happened. And you have eyes are starting to get really good at that time. So you have vision as a way to hunt and as a way to see your predator. And so you have that finally kicking into gear in these different lineages as really good eyes that really work, and you can actually see. Like, these are eyes that would actually give you a legitimate image of stuff instead of just being able to see kind of a hazy, there is light or there's not light, or I can hazily see something pass by me. You start to get eyes that could actually probably form pictures at that time onto a retina. So yeah, there's people debate a lot about it. I've got a book on that actually somewhere, but it's not. Yeah. Here we go. The Cambrian explosion. I mean, it's not the mystery that creationists put it out to be, but there is genuine mystery in there, like what triggered this. But it's not beyond what we normally see. And in fact, like after the extinction of the dinosaurs, you have this rapid diversification of mammals that go out and fill. It's called an adaptive radiation, and it's very similar to what we see here. The big difference, I think, would be that whereas after the dinosaurs went extinct, we see an adaptive radiation triggered by, well, there's a bunch of empty space here, and now we can fill it with mammals. In the case of the Cambrian explosion, it was probably it's anatomical innovations that triggered the adaptive radiation. So there's suddenly a lot more stuff that we can do with this anatomy. Uh, there are several genetic structures that we think finally took form there that are similar to what we have now, with master genes that control body shape and phenotype, and uh, those seem to really come into like full gear at that time, and that enabled a lot of this diversity. But again, people are going to debate quite a bit in the scientific field about what exactly triggered this, why it happened. But it's not like people who understand evolution and understand evolution dynamics, they're not blown away that how could this happen? It's how did it happen? There's lots of ways it could have happened. How did it happen? And that's the thing that they're writing about, that scientists are still debating.
Well, I don't know if I just wasn't taught it properly in school. I wasn't a very good student, but I actually learnt what evolution was properly by reading the book Refuting Evolution. So,
Nice.
well, when I say properly, I guess I didn't learn about it, but it's like, but I think this was one of the points that was in the book. But yeah, it's one of those things like polystrate fossils or something where the science will have a different word for it. Like Paul Leger did a video that blew me away, where you got polystrate fossils and then you have upright fossils, and then creationists will call it something differently so that you go to all their websites. But the geological literature says it a different way, but it's the exact same thing. And there's been an answer for it since like, I don't know, for like 150 years or something. Yeah. Genetic mutations are mostly harmful. Mutations are often harmful or neutral, so critics argue that they cannot account for the complexity and diversity of life.
Yeah. Most mutations are neutral or nearly neutral. And then when we talk about either beneficial or harmful, it's definitely fair to say most are harmful compared to beneficial. This is really what, Darwin wasn't thinking in terms of genetics, but Darwin believed that descent with modification, the changes that happen, those happen randomly. So like, let's say that you're on an island and it's going to be better to have a longer neck than a shorter neck. he didn't believe that the island somehow triggered long neck only mutations. He thought both were happening. Natural selection weeded out the short ones and favored the long ones. And that's really how this works with mutations as well. The mutations that are negative just get weeded out. It's not necessarily going to kill something to be less fit, but they're going to end up having fewer offspring. Like those with the less fit trait in a population where there's others with the fit version of that same trait, the ones with the less fit version, they're just statistically over time going to have fewer offspring until eventually they get completely outcompeted. Because a population's there's a carrying capacity for a population, and you can't go beyond that. So these things just get erased after a while. And that's constantly happening. And natural selection is constantly grinding against this noise that's coming in. It's constantly adding up the few beneficial mutations and deleting the many negative mutations. And it's a kind of a wasteful process, I suppose, but that's how it works. There are lots of ways that, if you look at if you look at animals, let's look at squirrels to take it off of humans, because there's lots of cultural things involved with humans that make it confusing. But with squirrels, the males and females, I'm talking about gray squirrels here, they do this thing when they're mating. The female will be approached by a male and she'll start running, and she'll run from tree to tree, and he has to chase her and he has to catch her to impress her. And if she's impressed, she'll let him mate with her. And they are doing crazy acrobatics. Like they're jumping from tree to tree. Sometimes they'll taunt dogs together. Like there's all kinds of funny things you'll see couples of squirrels doing when it's mating season. And what she's doing is she's like, in the case of squirrels, the male does not stay with the female, so she raises those kids on her own. The only thing he's giving her is good genes. She doesn't know that she's doing this, but she's testing if his genes are good or not. And if you have anything that's making you less good at chasing, doing acrobatics in the trees, you are just not going to get to mate. You don't get to.
Yeah.
So
interesting.
And this competition, this is with animals that can compete and do things like that, but similar things are happening even with things that don't have brains to decide. There's just, if you're not as fit, if you're a plant that's not as fit, you're not going to attract as many insects because your petals won't be as bright, and you're not going to be able to spread your pollen as far. And it's just, there's so many things that if you're not fit, you're not going to mate. And that's how natural selection, one of the ways, aside from killing things, that's also how natural selection keeps things clean. In spite of all the noise and mutation.
I was going to mention this before, but I've recently gotten back into growing chilies. I don't know. Do you like spicy food, chilies?
Oh, yeah.
Oh, cool. At one stage, I had 300 plants in my backyard, and my backyard's like only like 20 square meters. Like it was like you had to walk over little pots everywhere. I was trying to sell them and stuff, but I've got chilies from, Brazilian, like this chili, this white little grubby chili is only found in one part of the Amazon rainforest, in one part, and that's where it was found. And this chili is only, it was discovered here or was crossed with here. And I had like hundreds of chili. I think I had 50 something different species of chili. But something that I was quite disappointed to learn, because they weren't different species, but there were definitely different types of chilies, like different. I don't even know what. I don't even know if you call them a substrate.
Cultivar.
Yeah.
Cultivar. Yeah.
It's really frustrating because, you get all these people who would say, well, this chili kind of has a bit of a blueberry and smoke kind of a taste to it, and I'm watching all these reviews. And I'm like, okay. And this one's got this one's called Sugar Rush Peach, and it's quite sweet and zesty and fruity. Like, okay, cool. And this one, it's really hot, and it's it's peppery,
Yeah.
And then when you try them all, they all mostly just taste like chilies.
Yeah.
That's the main thing. Now, a chinense
Yeah.
a chinense is going to be usually really hot and really like fruity
Mhm.
and aromatic. An chinense, sorry, a capsicum anum, whatever, is going to
Yeah.
be a bit more like a Thai bird's eye. It's going to be hot and it's not going to be super hot though. And usually, and then there's Baccatum, which are going to be more sweet and stuff. And there's really the delineating line. But I just found it was so interesting how much you were saying noise. Well,
Mhm.
people, like, if I plant two chili species next to each other, there's a good chance that the bees will come along and they'll rub on one flower and then rub on another flower, and then the pods from that chili, the seeds from that, will be a combination of those two plants
Mhm.
in some
Yeah,
way, some way or
that's
another.
sexual reproduction in plants. It's supposed to happen that way, yeah.
Yeah, and that's why you get literally like I've got some chilies that I got from some website that were amazing, tasted really good, awesome and everything. But on the website it says we literally don't know where this come from, but we know that someone named Wendy bought it from a market in New South Wales here in the 70s. That's all we know
Yeah.
about it. But it's like this really unique chili, and it's like, whoa, okay, it's just so weird how there's such a diversity of plants. Just number 6, evolution. This is a weird one for me because I don't fully understand it. We've only got a couple left, but evolution
Oh,
violates the second law of thermodynamics. So the
people just
idea
don't
is
understand.
systems tend towards disorder, which contradicts the idea that life can become more complex over time through evolution.
Yeah. People who make that argument just don't understand thermodynamics or understand biology. It's one of the two. Um,
Yeah.
the yes, it's true that thermodynamics is about energy dissipating to where you can't use it for functional work. But the life is not in violation of the second law of thermodynamics. In fact, life increases entropy. Like if you were to ask what is the purpose of life and try and answer that question by just looking at what do all living things do, all living things increase entropy far faster than would otherwise happen. We are entropy producing machines, you could say.
Mm.
Uh, we take in the reason that we can form all this complexity is because we're using energy that's pouring into the earth from the sun, from an outside system, and we're using that energy to create this complexity. In the process, we create a bunch of infrared heat. We're dramatically reducing that sun's um, energy after it passes through us. We're putting out infrared. But yeah, we are like you can think of it as their claim is it's kind of like this. They're like, there's a second law that says there's a law that says that water only flows downstream. Well, then how is it that there's spaces every once in a while where the water flows up a little bit, or it's slow and swirly? Um, doesn't that violate the law of gravity, where everything has to go down? And isn't it downhill? It's like um, you're there's lots of
It's like the flat earthers will say water always finds its level, and it's just like it's a similar argument, right? It's like
yeah.
yeah.
So like there's entropy is increasing, but in that process of entropy increasing, some weird little swirls can happen, and life is one of those weird little swirls. And we happen to be a weird little swirl that increases entropy, like we speed it up dramatically. So yeah, you could say that the purpose of life is to hasten the heat death of the cosmos. um, but that comes to you know understanding thermodynamics, understanding what biology is really doing. There's a really great book, "What Is Life?" by Schrödinger, and
Not
he talks about the physics involved here.
not like Schrodinger as in Schrodinger's cat, right?
Yeah, same guy.
Oh
Yeah,
wow.
yeah.
Okay.
He wrote a book, "What Is Life?" and he describes this stuff really well, the physics of that. And then there's the PBS guy who does space time on
Mm.
PBS. Did a really good YouTube video about this, about
Phil.
entropy and life.
Yeah. Okay. Maybe I'm thinking of someone else, but yeah, but that's a cool series.
He's the guy with the beard, and yeah.
Yeah. Okay. Okay. Awesome. So I've got a couple more. The
Mhm.
origin of life. Evolution doesn't explain how life began in the first place. This is one that I wasn't going to bring up as a common objection against evolution, because it's not an objection against evolution, it's an objection against abiogenesis, but it's so common in the creationist space. In fact, Kent Hovind will say that he'll say like cosmic evolution, which is the Big Bang, and then life evolution, and he'll say that there are 6, I think, evolutions that happen, and he just uses the word evolution as like religious doctrines in the science world. So yeah, let's say that. But if I was to, I guess, steelman the position of there is no, if I was to steelman the position, I would say something like this. I would say we don't have a working theory with a theory of evolution because we don't know where, like, it doesn't explain where we came from, and it needs to explain where we came from. Otherwise, it's just kind of a, it's doing all the heavy lifting. It's not doing any of the heavy lifting.
Yeah, well, so there is a genuine gap in our understanding about the origin of life. So, in biological evolution, and this is, Kent Hovind, is that who you're talking about? That So, I mean, people do talk about like cosmic evolution, just how the cosmos have changed over time. I mean, the word evolution just means change over time in general. But when a biologist is talking about evolution, they're talking about biological evolution, which is this thing where when you have parents that have offspring, those offspring are slightly different than their parents and slightly different than each other. And natural selection, and the environment will end up favoring some of those offspring over others. That's it. Like, that's how adaptive evolution works. In order for that to function, you need to have something capable of generating offspring. You need something that can make copies of itself. And the big open question for the origin of life is, what was that first thing that could make copies of itself? And how did it come about? And those questions are not fully answered. They're not answered to any sort of consensus, right? There's lots of ideas about it, but there's not consensus on it. And so the argument you gave is that if scientists don't have an explanation for the origin of life, then that means evolution doesn't work at all, because evolution has to start with that. Well,
that's the steelman position that
and that's kind of like saying that you can't start building a puzzle until you've built the puzzle. Like, if you're working on a jigsaw puzzle and you've got a big chunk of the corner done, that's a big chunk of the corner done.
Yeah,
that's awesome.
True.
So
true. It's it's almost like you start with the edges of the puzzle, and it's like evolution is like the edge. And sometimes we have to swap pieces in and out, like when Darwin didn't know what genetics or DNA were, but the frame is there, and everything kind of relies on it in biology.
Yeah.
What an amazing analogy, David. Yes, I know, amazing. Sorry, the drinks have obviously taken effect. Number 8. No, there is no mechanism for addition of new information. So mutations, they argue, only degrade existing information. And this is kind of like the last one, but it's just a little different.
Yeah, so that's just nonsense. They're just really just making up nonsense. The types of mutations that we have mutations that can, so a substitution mutation, a point mutation will change one letter in the genetic code. So I shouldn't say letter in the genetic code, in the genome. Mm-hmm. So an organism's genome is all of its DNA that helps code for that organism. A point mutation will substitute one nucleotide, one little bit of that information for a different bit. That's a substitution mutation. You also have duplication mutations, where an entire chunk of DNA will get duplicated. And that dramatically increases the length of, it can. If it's a big duplication, it's a dramatic increase in the length of the genome, but it's a duplicate, so it's identical. We see that if you look at the human genome, if you look at the genome of any organism, you see that a lot of its genes came about through duplications followed by modifications, little modifications afterward. So you have gene duplications followed by modifications. You can also get inversions where a gene gets flipped, a chunk of DNA gets flipped, and then it can actually end up doing quite different things. You have chunks that'll get pulled out and then inserted elsewhere. Those types of mutations can happen. Those are called translocation mutations. And all of these different things can happen. If you look at just that list that I gave you, which is just a tiny amount of the types of mutations that are possible, switching out what's there with something different in a point mutation, duplicating something, moving something. What that means is that you can start with any sequence and you can end up with any other sequence over evolutionary time. Now, in practice, of course, most mutations are bad. They're deleterious. So it's hard to get from one specific, like if you want to set out and say, I want to go from here, from the genome of a monkey to the genome of a banana, like it's going to be very difficult to find a pathway that works without killing them in between. But evolution found its own path. Like bananas did not evolve from monkeys. They evolved from a common ancestor with monkeys that was a single-celled organism, and it was, you can get there from that ancient starting point. The claim that you can't get new genetic information is just completely false. I mean, we literally see it when we just watch things in the lab. We literally see it happen when we just look at how peppers are changing over time. If you look at their genomes, like, wow, there's something new in this one that's not in that one. That is new genetic information. This is the most well-observed, well-documented fact in biology that new information can pop up. That's what a mutation is. And it's really just word games that people are playing.
Okay, and last common misconception is macroevolution has never been observed. And what I wanted to first comment on was I remember seeing a debate between T-Jump and someone, a creationist, and he says he doesn't believe in macroevolution. He just believes in microevolution, but he believes that he essentially argues that there is no such thing as macroevolution. Everything is microevolution, but he doesn't deny evolution by natural selection, right? He says the person arguing in favor of evolution. He's essentially he actually takes out the word macroevolution and he just says, let's forget about the word macroevolution and let's just say there's microevolution all the way from a single cell to what we are today. They're just micro changes, and he starts from that presupposition because I hear a lot of creationists say that macroevolution has never been observed. And so, what do you say to that?
Yeah, these terms microevolution and macroevolution are not super well defined. So, real biologists talk about them, and people talk about, did something unusual have to happen in the transition of land animals to whales, for example? Or, are all of the changes that evolution uses, are they small changes or do large changes happen sometimes? And people define those words differently. And if you look at some of these arguments, people will be like fighting with each other in the literature back and forth. And then you realize that they're just defining the same term differently. It's very frustrating. It's so frustrating when I see stupid definition issues destroying real scientific discussions. It happens a lot. But then creationists, of course, confuses stuff a lot too. In short, like I do not see good evidence that oftentimes macroevolution is defined as the difference between species, and microevolution is defined as the changes within a population. Well, if you just separate two populations long enough, they're going to become different species because they're going to go through different mutations. One population will have access to a different set of mutations than the other one does. And both of those populations are going to be perpetually evolving to keep matching with the members of their population, so they're still sexually compatible. There's going to be selection pressure. If you're not sexually compatible with, I'm assuming like an animal that where there's sex involved here. If you're not sexually compatible with the members of the opposite sex in your species, you don't get to mate. So your lineage goes extinct, your mutation goes extinct. And that's going to happen differently in these two different populations, and you're going to get different anatomy that's just going to emerge, even if it's not evolving under selection pressure for something specific. Just they're going to diverge through drift. They're going to drift apart. And if you let that happen long enough, when you bring the two members of the two species back together, they cannot mate. They're no longer sexually compatible with each other. We've observed that happening even in labs. We've observed that happening. A lot of times there's lots of things that can cause that. There's tons of things, and some of them are so stupid. It's like this snail's shell is curled the wrong way, so it can't mate with that one, and it never can because it just can't reach. So there's silly cases like that, and then there's other cases that are almost equally silly, like, well, this thing doesn't recognize that one's mating call, so they never mate anymore. And then there are other things where they're just genetically they're not compatible. Like they'll mate and stuff, and the female might even get pregnant, and then she just keeps miscarrying, like always. So that happens, and at that point we're at macroevolution, if you define macroevolution as the species level, when you get to new species.
Hang on a sec. I've got this book.
Yeah.
You might be the only person that actually appreciates this book from a scientific perspective. It's called, have you seen this book before?
No.
Biological Exuberance, Animal Homosexual and Sexuality and Natural Diversity. So I actually got this. This is a Ricky Gervais bit, and because there's just it's just essentially hundreds of case reports of different same-sex animals banging.
Awesome. Yeah, that's awesome.
It's actually really interesting. Cool. They've got diagrams and images, and they've got lots of cases of lots of social species where it's like, well, we see like a percentage of like pair bonding or sexual or like raising a child, and they see same-sex interactions even in the animal kingdom, and it's just really
it's very, very common. There is one thing I do want to talk about before we go, though, and that is this lawsuit that just happened. Yeah, so there was this lawsuit. Let me just read you part of this article. This is an article from Deseret News, which, by the way, it's a Mormon news channel, but they said, so Christian parents in Indiana were fighting to force changes to Indiana's state standards for science education to get books referencing evolution out of public school classrooms. The family's main argument was that teachers violate religious freedom laws when they promote the, quote, atheist religion by teaching students about evolution. The parents who filed this lawsuit, Jennifer and Jason, argued that schools that teach evolution essentially choose sides in a faith-based debate, thereby violating the First Amendment's prohibition on government establishment of religion. Quote, because the atheistic theory of evolution specifically attacks the Judeo-Christian origin story, it has the purpose and effect of advancing the atheist religion. The federal district court judge, Sarah Evans Barker, wrote in her ruling that they had misinterpreted the Establishment Clause. Despite the plaintiff's assertion to the contrary, the purported similarities between evolution and atheism do not render the teaching of evolution in public schools violative of the Establishment Clause, which has never been understood to prohibit government's conduct incidentally through coincidence harmonizes with the tenets of some or all religions. I just thought this was super interesting. First of all, like her claim, the judge responded brilliantly. Like, that's such a good professional way to explain this. Like, but I just thought this was interesting because I can sympathize with those parents in a way, because there's been such a marriage on the internet. Like, if you go online, between atheism and the theory of evolution, I think you could get confused, especially if you're in like a crazy, I don't want to say crazy, but if you're in a very fundamentalist circle, that you're just going to think evolution is literally a doctrine of atheism. and that atheism is a religion, and you're going to see that when you get online. I just thought that was interesting. I wanted your take on that, because for you, it seems like evolution actually was something that, for me, it was not important in my leaving my religion, but for you, apparently it was. And what your take on this whole scenario is.
Yeah, it's hard because it did become, it's so connected. I remember seeing a preacher at Planet Shakers conference, that I think it was at Planet Shakers conference. It was Jürgen Matthesius, I think his name is, and he said, "Why do you blame?" Like he screamed, "Why do you?" He's like, if you teach people that we come from animals, why do you blame them when they act like one?" And talking about like degeneracy in the culture or whatever. And it was very, very tied in with a lot of on the fringes of like my I guess religious experience. For me, I've told this story a bunch of times, but for me, when I was first deconstructing, or like looking at the evidence. I didn't think I was deconstructing at the time, but I was looking at the evidence. My wife, Amy, bought me tickets to the Faith and Science, well, the Brisbane Science Festival, and it was a faith and science talk. And on stage, there was like a Buddhist, a Catholic, a Muslim, a Christian, and an atheist. And they're all scientists. Well, most of them were scientists. And they were all saying that there is no problem between their religious beliefs and their science. And then it got to the atheist who said, I think that, I think I've just been brought here to disagree with everyone because I disagree. And they said, science starts from a perspective of trying to disprove everything it can about something. It tries to disprove things, where religion protects its beliefs. And he basically said, like, you can go into a science classroom or a science lab, and you can kind of act as an atheist or whatever, but your religious beliefs, you have to kind of go in there as an atheist. Like, you have to go in there just trying to disprove things. Anyway, that person was A.C. Grayling, and I didn't know who that was, but afterwards I got a book signed by him. I got a photo with him, and when we're walking down the stairs of that the auditorium in Brisbane, Amy, my wife, said to me, "I think what you're doing is good. I think you're doing a good thing." And it was like at that moment she realized how important it was to investigate what we believed and why that was important. And I guess from then I felt like I had her blessing, because we waited till we were married to sleep together. We were very religious, and but it was for me, it was like it gave me the freedom to then explore the evidence without bringing in the baggage of my religious indoctrination.
Yeah. Yeah. What he was describing there is called methodological naturalism, which is where you don't actually have to be a naturalist or think that just nature is it, but when you're doing your science, you assume that there's a natural explanation for this thing, and you try to find that natural explanation. That was very important early on in the philosophy of science, to try and get, when the Catholic Church was funding all the research, it was hard to do that because your funder wants everything to fit with their doctrines. And so this thing popped up, like, okay, well, I shouldn't get in trouble for finding something different than what the Pope said, because I'm doing this project, which is just studying nature and trying to figure out how it works. And that that became a very important part of science. So, and that's what he was describing. So, like, if you are religious, when you get into the lab, you're looking for the actual immediate mechanism as to how this thing works. Because you could just say that everything's a miracle, right? You could just say that, why does beer ferment? Why does beer bubble? Because God made it bubble. I mean, it's a good enough answer, right?
Yeah.
uh,
And it's
so
interesting. I've got this book of ancient magic from Greece, Greek and Roman magic. Weird collection of books I have, and in this book, it gives an introduction, and it says, ancient Greece and ancient Rome is like magic and the objective reality. They weren't like two separate things. They were like everything was kind of magic, and they say that like he says, you plant a seed, an acorn, and then a tree grows from it. He's like, that's like a potion. That's like magic. That's like, how does that happen? And sometimes these trees even have spirits in them. I forgot what he used, but it was interesting because that narrative, that idea of the world, actually served its purpose for a long time. Like, it gave people stories to understand the universe, the world, and everything. And when someone asks me, like, well, that's a story, and then science is a story, they'll say, like, science is also a story, right? And I would agree with that to some degree, that science is a story. I'm not one of those people who think that we've got it all figured out. But what I love about science is, again, going back to what I said earlier, is you can make novel, testable predictions. You can make predictions about things. Another great example that we have is, I don't know what formula it is, whether it's Newton's something. Anyway, we find Uranus, or we find Neptune. I don't know which one's actually further or closer. I should, but I keep forgetting. And we're like, okay, we find it in the sky. We didn't. The ancients didn't know about it because you needed a telescope to see it. We finally see it, and we're like, whoa, big planet out there. That's crazy. And we're like, okay, so it's moving in this direction. Therefore, at this time, it should be at this location in the sky. It wasn't. And they're like, okay, well, it's not there. So therefore, there must be something else with this mass or this size, generally pulling it away from its location, and that location should be around here. They pointed the telescopes there, and they found Neptune or Uranus, whichever one I'm forgetting.
The other one. Yeah.
The other one. And that's crazy. So that's another thing where it's like, it's so novel and testable, and it made such a firm prediction that for that formula, whatever they use, whatever Newton or whatever, Neil deGrasse Tyson, whatever they use to come up with that, for that to be wrong or incorrect, like in some way, would be incredibly strong coincidence. Like, you can test it.
That's a beautiful example of everyone works hard building a model for how we think it works based on what we can see. Then we use that model to go make predictions about what else is out there, which, if you compare this back to the puzzle making that we were talking about earlier, this is like, as you're building a puzzle, suppose you don't know what the picture is supposed to be at the end. You start to figure it out as you're building the edges and so on. And you're like, oh, I think this is a picture of cats or breakfast food or whatever. And then once you start to have a picture of what it is, what you're supposed to be looking for, it's way easier to go look into your pile of pieces, little observations, and figure out where it is that they fit. So we use these models to not only to have an explanation for the facts we already have, but to also tell us where to look for new facts and what to be looking for when we go out there. And evolution does that like crazy. You mentioned some things with the fossil record. It's everywhere.
When I kind of realized the weight of evolution, it actually became a bit of a spiritual thing for me. It became like a, whoa, like I'm part of this massive thing. Like it gave me this freshness of life. And it also became funny to think that we didn't want our dog humping pillows, our beagle, when he was a puppy. So we brought him to the clinic and we got him snipped, cut off his manhood. And I just think 3.4 billion years or something that lineage has survived. And for just our inconvenience, we just didn't want the inconvenience. So that all gone. Just stop that lineage. It's like just incredible, like that we did that. Like 3.4 billion years, or 3.2, or however long, billions of years.
Well, if you want to feel better about that, you did buy a dog from a breeder, I'm assuming.
Yeah.
So you paid someone to take care of the mother that has those genes and make sure those get passed on into the future. So this is something called indirect It's called inclusive fitness, where
That's
a
awesome.
species doesn't pass its literal genes on, but it passes copies of its genes on somewhere else. And you
Okay.
paid for dog food for his mom to make more babies, so you
Hey, there
contributed
we
to
go.
his reproduction
That's so good.
indirectly.
I have. Is it okay? I've got two really short clips that I can
Yeah.
show. Is it okay?
Mm-hmm.
So
Yeah.
this one, I wasn't going to show this. This was going to be my last clip to show, and then I decided not to show it because running out of time. But I think it actually really fits what we're talking about.
Mm-hmm.
And I just want to get your perspective on this. This is Alex O'Connor. I'm sure you've heard of him before.
Oh yeah.
But it's just a short video. And he's an atheist content creator, but he's also got a philosophy degree or theology degree, I think. Anyway, check this out.
And the mistake that makes, this is crucial to me, is thinking that scientific laws somehow explain the universe instead of just describing them. It would be as though we discovered a book of Shakespeare's sonnets and said, how did that get there? And we say, I don't know. And I start studying it. And I say, well, look, I've just discovered it follows this rhythm. Da, 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 da. And I'm going to call that iambic pentameter, the law of iambic pentameter. And I've also discovered this law that at the end of a sentence, there's usually a little dot. That's the law of punctuation, and how after that there are two types of letters and the big letter comes next. All these laws that I'm discovering. And someone says, well, where did the book come from? And you say, well, I mean, I don't know. We haven't answered that yet. But look at how much progress we've made in uncovering the laws of literacy. Surely one day this will come to explain the origins of the literary laws themselves and the origin of the book. It's a category error. It's a total mistake.
That could almost come from a Christian trying to put science in its box. We've chosen a very forgiving atheist on this.
An atheist who practically sounds like he believes in God at this point.
I've got to ask, do you feel like there is any chance if we get you back in 10 years' time, you'd have a different answer to that question?
God willing.
I thought that was really clever kind of analogy. What do you think about that?
Well, that is so. Well, he's right on for things like the Big Bang. The Big Bang does not describe how the universe came into existence. It describes what happened after it came into existence. It does not explain how it came into existence. Evolution explains how organisms became how they are, but it also doesn't explain how the first organism came about. So he's right. His analogy makes a lot of sense for those types of questions. So in science, we put question marks there where we don't know what happened at that point. In religion, people put that's an argument for God in many cases. But where his analogy kind of breaks down is like, well, so in evolution, for example, we have described the process and a bunch of observations of it. Like we know that this is how animals diversify. We know that this is how plants diversify. We literally watch it happen in the lab. We look at it happening in the fossil record. So just by describing, he's right, science is describing how things happen and what's there. And in the case of evolution, we've been able to describe so much of what's there that the old story we had doesn't make any sense. And that's why in this case, there seems to be a conflict for a lot of people. When people want to hold to an old literal interpretation of the Bible for how life became, different life forms came to be, it just doesn't make sense anymore. We've described too much of how it actually worked. We can't believe in that story anymore. And so what Christians are left to do is either find a different way to think about the creation that involves evolution, or consider it to be a mystery. We don't know why our religious story and our scientific story doesn't make sense. That's what the Mormons have chosen to do. They just kind of let it be a mystery. The conflict be mysterious. And then others reject the science. Those are the three ways that people deal with it. So I kind of taking that back to, I want to take that back to this lawsuit, but before we do that, does that make sense? What I just said?
Yeah, that makes sense. Yeah.
So he's making a very cool observation here. Like, I had my cousin ask me, well, you're not religious, but what is the Big Bang doesn't tell us. What does it tell us about how the universe started? And like, it doesn't tell us anything. It tells us what it was like very early. It doesn't tell us anything before. Like it's just a question mark. We don't know what happened before the Big Bang. We don't even know if that question makes sense. Because that's when space time emerged, right? So yeah, there's lots of questions that we don't have answers to. I mean, science isn't here to just give us an answer to every question we have. It's here to give us answers to questions that we have answers to, and then it's here to find answers to those questions. And things can be mysteries for indefinitely. We don't know if we'll ever know what happened before the Big Bang. That's just how it is. And
it might be nonsensical to even ask that, right? Because time, yeah.
You can put God there. That's totally fine. You can put whatever you want there. You can put a giant purple invisible origami peacock there. That's what started the universe. Whatever you want to put there, you can put there. Scientists will put a question mark there. But with this lawsuit recently, with these Christian parents thinking that evolution is a doctrine of atheism, it's a confusion. It's not a doctrine of atheism. It's just us describing how nature works. But a lot of atheists have adopted it as a talking point. And that, to me, as someone who really just wants to teach this science, that can be very frustrating. Because it's adding an extra barrier for these kids. So I really appreciate organizations like BioLogos that are trying to help Christians cope with it and just talk about it in more ways. I appreciate this stance that BYU has, where it's like, yeah, there is a conflict here, but let's not worry about that. Let's just do the science when we're doing science, and we'll do the theology when we're doing theology. And some people will get curious and want to deal with this, but they're going to be speculating only, and someday we'll figure it all out, probably. So I think those are healthy ways to deal with it. And I feel sorry for this couple that honestly believes that this is evil and being taught to their kids. And I do wish that the people in the comments on my videos wouldn't be so hardcore about trying to use evolution to teach atheism in the comment sections in my videos, because that's not what I'm trying to do. I'm just trying to teach biology, and I think we'd be better off just teaching biology.
Yeah, exactly. It's not so like political in other countries. Like in America, it's like, and I'm not sure about Canada, but it's crazy, like compared to where it is everywhere else.
Yeah.
Well, I've got one last video to show you, and then we'll end the podcast. This is the shortest scientist versus creationist debate ever. It's one of my favorite videos on YouTube. And it goes for 30 seconds, and I just want to know what you think. Okay.
Immense amounts of time are required to deposit that, cement it into hard sandstone and shale, tilt it, erode it. Your minimum estimates is hundreds of millions of years.
Don, thank you for your talk so far. Number one, your assumption was naturalism.
Yes.
And your second assumption was uniformitarianism.
As all scientists around the world are.
Well, not all scientists. That would be a false statement, so it would.
Well, all scientists I'm aware of.
Really? So you've never read any creationist literature?
Oh, I've read them. I don't count them as scientists.
Ah, right, okay.
I don't know why that is so funny to me, but it's just so symbolic of the whole conversation around everything, right? It's like creationists will go, youngest creationists will pull out their scientists, and scientists go, well, they're not real scientists, and it's just like, okay.
Yeah, I mean, he's kind of doing an argument from authority. That's Prethro. What's that guy's name? Do you know who that is?
I'm not sure. It's part of this documentary that taking creationists around to try and show them evolution and see if it can change their mind and stuff. So
yeah.
That
guy. He's done a lot of good stuff. He's written a lot of books on like paleontology and stuff. He doesn't have a whole lot of patience for creationists. I like to take a more patient journey there, and not make any arguments on authority, and just show people the observations is how I like to go about this. Like this is what we see, and this is what we think that those things mean.
Yeah.
And at the end of the day, I mean, there's this saying, how's it go? extraordinary claims require extraordinary evidence. You've heard that, I'm sure.
Mm-hmm.
Well, what is an extraordinary claim? It's whatever thing you happen to find hard to believe. It's the audience who decides what is an extraordinary claim. So I do think that depending on our audience, we have to give them more. I mean, they're not going to accept, and there's just certain things that people will not accept because they have other beliefs. But what I do in my work is I try to assume that my audience is genuinely curious and is reasonable. And that's the audience that I'm going after. But I also consider them to be skeptics. So I consider that they are skeptical of what I'm telling them, but they're reasonable. And if I show it to them, they can understand it. And that having that as my target audience it's worked. And I've used myself, like when I was in high school, back when I was still leaning pretty hard into creationism. That's kind of the target that I think about when I'm doing these videos. What would be convincing to that guy back then? So.
And you do a really good job of it. I'm going to link. I think it's might be your most popular video. What are the evidences for evolution? Is that your most popular video? I'm going to link. That's my favorite, even if it is or not. But
that's my most popular non-short. Yeah, that's my most popular long video. Yeah.
Well, I'm going to link that in the description. You've got two channels that at least I'm aware of. Stated Clearly, which are more like kind of produced animations, and then you've got Stated Casually as well, where you do kind of longer form content, talking to scientists or discussing certain ideas. And you have a really good series. I don't know which channel it was on, but you talked about the fossil the soft tissue inside fossils inside dinosaur bones, and
I did that. That's a Stated Clearly animation.
Yeah, really good stuff, and you're really well researched and fantastic. So make sure you go check out Stated Clearly and Stated Casually. Links in the description, and of course buy your t-shirts. They're pretty cool design. Charles Darwin, eh?
Here we'll
so
get it.
Good.
There we go. And it's got a signature on the bottom,
Oh, that's so good. Oh, that's so good. Yeah, that's cool.
And a little shout out statedclearly.com.
Yeah, that's awesome. That's awesome.
That's the most recent t-shirt on the Stated Clearly YouTube channel. You'll find that underneath videos. You'll find a link to that, but I can send you a link too. Yeah,
that's so good. Well, they'll link up the link in the description. Thank you so much, Jon, for coming on. You've been a huge part of my journey through life. And I thank you so much for responding to my email all those years ago. I know that you're a very busy person, but thank you so much for creating the content you do, and I really appreciate it. And thanks for coming on Deep Drinks.
Yeah, that was fun. Cheers.
Cheers. Thank you to everyone who financially supports this channel, and a special thank you to the Archbishops of Deep Drinks, Jason Rollins, Matthew Monga, Digital Hammurabi, and Eric from Skeptics and Scoundrels. If you'd like to support this channel and see a cartoon avatar of yourself, check out patreon.com/deepdrinks.